All right, good morning, class. Today we're going to work on the second piece of circles here, dealing with the equations of circles. Whether we start with the equation as we do here, or whether we come up with an equation. So we'll see that throughout these slides here. So, standard form of a circle is this equation right here. X minus h quantity squared plus y minus k quantity squared equals r squared. The center of the circle is h comma k, the h and the k here. The radius comes from taking the square root of radius squared. That gives me the r. So, very simple. Remember, minus, another word for minus means opposite. It's the opposite of this, the opposite of this. And that's what you'll see right here. That's why you see the words opposite. So identify the center and radius of the circle. Start out nice and easy. So that really says x minus 2, right? Positive times a negative is negative. So x minus 2 squared. The opposite of minus 2 is positive 2. That says plus 9. The opposite of plus 9 is minus 9. And then I have to take the square root of 18. Remember, the square root, r equals the square of 18. Now I have to simplify that since it does simplify. If it did not simplify, I would be done. But the square root of 18 breaks down to the square root of 9 times the square root of 2. And the square root of 9 equals 3. So it's 3 root 2. Remember, you're looking for perfect squares that would go into it. 1, where it doesn't do any good. 4, 9, 16, 25, 36, 49, 64, 81, etc. Okay, you'd be looking for a perfect square, so obviously 9. You only have to start with half that number and work your way down. So 9, if that works right away, it's 9 times 2, which it does. So square root of 9 is 3. If that didn't work, I'd go down to 4. Obviously 1 doesn't matter because you're not breaking down 1 anyway. These are your perfect squares. So if I said PS on the board, that stands for perfect squares. Okay. All right, so we've identified center and radius. This is on the part doing this. You're going to have it on your quiz, obviously, tests here. We're going to start, like I said, we're working part of the circle stuff now and the majority of it later next semester with the unit, but there's so much with circles. I don't want to have to cram it all together at one time and be having to go through fast. So I pick some of the tougher concepts, especially the equations writing them coming up today. To put in here now, so we're not having to spend a lot of time on it when we get to it in the unit. We'll do it again in the unit, so you get tested on it then as well next semester, but it should then be complete review because you'll be doing it from here on out. So again, another equation here. We do the opposite. Opposite of 3 is negative 3 for the x coordinate. Opposite of 4 is negative 4 for the y coordinate, and the square root of 81 is 9. So what I want you to get, as it says, get used to saying this out loud in class. If I give you an equation, how do I find the center and the radius? You're going to tell me the opposite square root. That's all you say, opposite square root, and then you actually do that. Okay, so that's easy as can be doing that. Okay, now we want to graph that. Graph an equation from standard form. So again, I have to identify the center and radius. Opposite, square root. So the center is 1, negative 2, plot 1, negative 2. The radius is 3. So that means I go up north 3, east 3, south 3, and west 3. Put those 4 points there, and then just do your best to make a circle from there. But I'm looking for the center being identified in the 4 points, north, east, south, and west, going out that radius distance. Okay. All right, next page. A circle has this equation. What are the coordinates of its center and the length of its radius? So here it'd be a part type of question. Remember, opposite, square root. Negative 1, 3. Negative 1, 3. And square 16 is 4. So negative 1, 3. So the answer is 1. Negative 1, 3. Radius 4. Okay, the same thing again here. Opposite, square root. So 1, negative 3 is the center, radius 3. So I can just immediately wipe those two out because radius is 81, radius 3, and it's 1, negative 3, 1, negative 3. So the answer is number 3 here. Right, the equation is this. What are the center and radius? So this time, it could, if they don't give you as multiple choice, they'll give it to you as fill in the blank. Okay, and they'd have 2 boxes, one for the center and one for the radius. So remember, it's opposite, square root. Remember this, see, there's no other x here, it's not an x minus something, so it really says x minus 0. It's the same thing as x minus 0, but x minus 0 is x. That's why you're not going to ever see it written as x minus 0. So that's 0. The opposite of negative 7 is positive 7. So we have 0, comma, positive 7 for the center, and the radius equals the square root of 16, which is 4. So each one of these would be a separate block that you'd be filling in. Same thing here again, opposite, opposite. 3, negative 8 are the two opposites for the center. Radius equals the square root of 39. The square root of 39 does not break down. So that is it. Square root is 39. If it broke down more, we would need to break it down more, but it does not. So you are done right there. Square root 39. Okay. All right, next page. So now another thing they could do is they could give you the equation in standard form, and they have graphs, 4 graphs for you to pick from to choose which circle is graphed from this equation. So again, identify the center and the radius, opposite, opposite, square root. So we got 5, negative 1. So right, 5, comma, negative 1, and radius equals 3. So obviously we're looking for radius of 3. That's going to be these ones here, the smaller ones. These radii are both way bigger than 3, so you can wipe those two out. So now it's just which one has the center at 5, negative 1. Well, 5, negative 1 is over here. This is negative 5, positive 1. So what they did here, trying to trick you, is if you forgot it wasn't opposite, opposite, you did same, same. Negative 5, positive 1 is that one right there. If you did same, same, it's never is anything we're doing is same, same. Always opposite, opposite, square root. Just know that. So that should be nice and easy to pick out. Same idea here. Negative 2, 0. Remember, if it's just y by itself or x by itself, that means it's 0 for that coordinate. So negative 2, 0. And the radius 4. So again, we're looking for a radius of 4. Well, these radii are 16 each, or 8. It looks like 8. 1, 2, another 6, 8. So they must have just divided by 2. So they thought, in case you didn't know square root meant take the square root, which is square root of 16 is 4. If you thought square root meant just divide by 2, then you would pick one of these two. That's not what square root means. What number times itself? 4 times 4 is 16. So now we're down to these two, and now I just have to identify the correct center. Negative 2, 0 is right there. That is positive 2, 0. Again, that's if you did same, same. So our answer right here is number 3. Okay. And I forgot to circle this one over here. 5, negative 1 right here. So it's number 1 with the radius of 3. Okay, next page. So see this. So we start out nice and easy. Okay. One more. Now, if they go ahead and give you the circle itself, and they want you to come up with the equation. Okay. So I look at the center here. I count 1 and then up 1, 2, 3. So the center here is 1, 3. And the radius, now count, again, I can go either north, east, south, or west, count until I get up to the circle. 1, 2, 3, 4, 5, 6, 7. Radius is 7. Okay, there's my radius, 7. So remember, when I do my equation, it's r squared, so it's going to be 49 on this side is r squared. So now it's down to these two. I can wipe out those two right away. It's not 98, it's 49. Now, look at this. 49, well, we already know the radius is 7, not 49. So we already know right now, just from looking at the radius from this particular one, it's this equation. Of course, we can check it here. Remember, it should be the opposite of the opposite. So negative 1 and negative 3, which is right there. Okay, so same idea again over here, another easy one. Okay, so we go ahead and identify the center, negative 1, 2, negative 1, 2, and count until we get to the circle for the radii. 1, 2, 3, 4, 5, 6, 7, 8, 8. Okay, so remember it's r squared on the right side, so 8 squared is 64, so it's one of these two. Okay, so we can wipe out those two, and we know the radius is 8, not 64, so we can wipe out that one. And so again, we're already down to this one without even having to look at the center yet. Okay, but you still should know it. It should be the opposite, and the opposite should say a +1, which it does, and that should say a -2 right there for the opposite, or it's opposite, opposite, and then square it. So if we started from this, If we did opposite, that'd be negative 1, 2 right there, and the square root of 64 is 8. So we can check it like that as well. All right, so those are the easy ones. Now, starting from the standard form of the equation or looking at the graph itself, okay? Oh, one more, I guess, but a little more work. One more piece of work. Okay, write the equation of a circle passing through the point 6,5. So there's my center. Oh, passing through the point 6,5, centered at the origin. I'm sorry, centered at 3, negative 4. Okay, so here's my center. They tell me that's my center. Remember, this side over here deals with the center. The right side deals with the radius. So remember, it's going to be opposite. So if you see an x minus 3 squared and a y plus 4 squared, well, both of those have that. Okay, so we can wipe out 1 and 2 right now. So it's down to these two right here. So now the question is, what's the radius? Well, remember, the center's at 3, negative 4, so I plot that, and it goes to the point 6,5. That means that 6,5 has to be on the circle. So I need to go ahead and find this distance. And remember, another name for distance formula is the what? Should already have said it, Pythagorean theorem. So we're just going to go ahead and draw ourselves a right triangle and do Pythagorean theorem. Okay, so we count 1, 2, 3. So that's 3 there. And how many are we going up? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So remember, it's a squared plus b squared equals c squared, or in this case, it would be r squared for the radius. The c is the radius. So 9 squared is 81 plus 9 is 90. That's r squared. And remember, r squared is what's on the right side. I don't have to take the square root of this. This is r squared. So there's my 90 right there. So 4 is my answer. Okay. I just plotted the center, plotted the point they told me that was on it, drew myself a right triangle, used Pythagorean theorem to get what r squared is. And that goes on the right side, r squared. Okay, let's do it again. Okay, center is 2, negative 3. There's the center, and it passes through 6, 2 right there. So again, draw myself a right triangle to figure out what this radius is. Remember, this is the r right here, the radius. So I'm trying to figure out that length. Okay, so now go ahead and count 1, 2, 3, 4, and 1, 2, 3. Let's see, 1, 2, 3, 4, 5. Okay, so 5 squared is 25 plus 16 is 41. Remember, this is r squared, so we want it to be 41. So we can wipe out these first two. That's just r. Square root of 41 is r. But r does not go in the equation. It's always r squared. So it's one of these two. And now we just have to match up the center correctly. Center was 2, negative 3, so remember it's opposite. So it's going to be x minus 2 right there and y plus 3. So it's number 3. All right. Now we get to some work here. Complete the square to find the center and the radius of the circle. Okay, remember, here's our standard form of a circle. We've been working with that all along here. Our opposite square root. Okay. Well, we need to remember the standard form of quadratic is ax squared plus bx plus c. Okay. They're going to give you this ax squared piece and the bx piece only. And they're going to want you to find c for both the x piece and the y piece. So to find c, when a is 1, which is what it's going to be every time, given some b, and you don't know c, that's what you're trying to find c. How do you find c? You do 1/2 every time, 1/2 of b, whatever this coefficient of the x is, or the y, if you're talking in terms of y, 1/2 of the b, and you take that number and square it, and that is my c. Okay, so we're going to see that here. So here's an example. They give you this equation right here. Say, complete the square and find the center radius of the circle. Guaranteed on the park. Okay. So step 1 is to get the x's and the y's to one side. Notice this in this particular equation is already done for us. And the constant's the other side. Here's my constant on the other side of the equal sign. Okay. Step 2, arrange the x's together and the y's together. They've already done that one for us, and the y's are together for us. So if it's not given like that, I need to rearrange that. We'll see that on the next couple examples, and we have to do it ourselves. Okay, but this one, they already have it arranged for you. Start out a simple one. Put a blank for both c's. Remember, here we have it. Our a is 1, our b is 14. We don't have the c here. Here, a is 1 for the y squared, b is negative 4. We don't have the c on this one. That's why we're trying to find the c up here. That's where we're going to use the 1/2 b squared coming up. So put a blank in. So I put a blank right there for the c, a blank right here for this c, and a blank on the right side. Because whatever we add here and here, we have to add to this side. Whatever you do to one side, you must do to the other side. Okay. So that was step 4. Put the blanks in there. After you put the blanks in step 3 in the other side. Step 4 now is to find c, this c on the x and the c for the y, and then add it to the other side so you don't change it. Okay, so again, how do we do it? We already set up here 1/2 of b. I wrote it down here. 1/2 of b is 14. Half of b, half of 14 is 7. Squared is 49. 49. Here, half of b, don't forget the sign, -4. Half of -4 is -2. Squared is +4. Remember, whenever I square a number is always going to be positive, so you better not ever have a negative written here. It's always going to be positive. That's why you can say plus blank. It has to be a plus some number. It's got to be a positive number here. So we added 49 for this one to complete the square. We added 4 to this one to complete the square. So we added 53 to the left side, so we have to add 53 to the right side right here. So now we factor this. This is a perfect square trinomial. It will always factor into the square root of this, the square root of this, and the same sign as the middle sign right here, +7. A simpler way to think of it, it's always going to be x. In this case, it's always 1/2 of b. So if I were written half of 14, that is 7, and then that's, then that's 7 squared. This right here is always what this number is right here. Since that's a +7, this is a +7. Okay, but you can also look at the middle sign right here to make sure you have the right sign as well. Okay, so again, over here, this y squared minus 4y plus 4 factors into y minus 2 squared. Again, it's always half of b. Half of -4 is -2. Okay, so there we go right there, and there's my -2. So it's y minus 2. I don't have to put plus minus, it's y minus 2 quantity squared. Don't forget your squares. It's always squared. That's a standard form up here of a circle. X minus h squared plus y minus k squared equals r squared. There's a squared on each one of these. Okay, now if it's a number, sometimes they actually square out the number, sometimes they leave it. So if the radius is 7, sometimes they'll leave it as 7 squared on the park. Other times they'll actually calculate out 7 squared and put a 49 here, as we saw in the previous examples on the multiple choice. So it just depends. If they want it to be 7, that's when they might have you fill in r being 7 here in the equation if it was on the park like that. Okay, and then lastly on the right side, 2 plus 53 is 55. So now we have our equation right here in standard form, just like this right here. And then we do the opposite square root, like we've been seeing on the previous page that we did. So the opposite of 7 is -7, opposite of -2 is +2, and the square root of 55 does not simplify, meaning there is no perfect square that goes into it. Remember, the perfect squares we're checking are 4, 9, 16, 25, 36, 49, 64, etc. Remember, you start with half of that, 27. That's not there. I go down to 25. Does 25 go into 55? No. Does 16 go into 55 evenly? No. Does 9 go into 55 evenly? No. Does 4 go into 55 evenly? No. So that means it does not break down at all. Now, if you didn't know if they divided evenly into these things, you can put in your calculator and check. But a perfect square has to go into this right here in order to simplify this radical. None of them do. All right, so now let's go ahead and practice a couple more of these here. So here, something like this you could be given on the park in this format. X squared plus y squared equals 6 plus 8x minus 14y. Remember, steps 1 through 3, we're talking about putting the x's and the y's together on the same side. So notice and put the x's together and the y's together. So I have x squared minus the 8x plus the blank. I got to solve for the c, plus the y squared plus 14y when I add it across, plus blank for that c, equals the constant c on the right side. Okay, so putting those blanks in there, that was organize my y's together and my x's together, plus the blank. That was your steps 1 through 3 on the previous page. So now we need to find the c, just like we did in the last page. We take half of b every time. I got it written right here. If I say, how do you find c? You're going to tell me half of b squared. That's all. Everybody in the class should say half of b squared. Okay, so half of -8 is -4 squared is 16. Half of b, there's b again. What's half of 14? 7 squared is 49. So since I really added 16 plus 49 on the left side, I have to add it to the right side. 49 plus 16 is 65. So I have to add 65 to this side. 65 plus 6 is 71 right there. And again, now I factor this perfect square trinomial. Okay, again, it's always going to be x and then the square root of this and that middle sign. So 4 and the -4. Or I can just look right here. If I do the half of b correctly and write it down right there, that just goes right there. Okay, half of b, 7, goes right there. Now, if you've been blowing it and not putting the right signs with it, then you need to go back and check. You're checking the B sign. It's got to be that sign, positive, positive. It's got to be B sign, negative, negative, in case you aren't putting the correct half of B down here. Okay, but if you're doing this half of B right, you can just slide that right into there and slide that right into there. Okay, so there's our equation in standard form. Remember, squared, squared, and then 65 plus 6 is 71. And now remember, we're not done. That's if it just said put it in standard form, we'd be done. Standard form circle would be done. That'd be the answer. But it's asking for the center and the radius. Remember, so it's opposite, opposite, square root every time. 4, -7 for the center. Square root is 71. That does not break down. There is no perfect square. The 4, 9, 16, 25, 36, etc. None of those perfect squares go into 71 evenly. So it does not break down. All right, here's another one you can see. You're gonna only have like one of these, but you don't know like what format they're gonna give it to you. They can give it like that, they can give it like this. So again, remember all the x's and y's to one side. I want my x squared to be positive, I want my y squared to be positive. Since y squared is already positive here, we're leaving this here, and we're moving this negative to the other side. So all the x's and y's are going to the left side. And then I put my x's together. So I have x squared, when I move this across, it becomes -4x, got a plus blank, plus the y squared, move the -4y becomes plus 4y, plus the blank to solve for the c, and the constant stays on the right side, -4, right there. Okay, then every time, half of b, half of -4 is -2, squared is 4. Half of b, half of 4 is 2, squared is 4. So I really added 8 to the left side, so I must add the 8 to the right side. And now that perfect square trinomial factors nicely into x minus 2. Remember, I can slide that down here if I've done this correctly. I'm not confident I did it correctly. Check that sign. It must be that sign, the negative right there. Again, half of b, 2. Right there, if I want to check it, it must be that b sign right there, positive. It is positive. And then 8 minus 4 is 4. So now we have it in standard form. Again, we're not done because they want center and the radius. Center and radius. So opposite, opposite, square root. 2, -2, and the square root of 4 is 2. There's our answer right there. Okay, write an equation or circle with points on the end of the diameter. So notice we are not given the center yet. We only know 2 points on the circle. It's in a diameter. We know the midpoint of the diameter is the radius. Is the center of the circle. So I need to find the center. I need to find the midpoint between these 2 points. That is the center. So we use the midpoint formula. Here is the midpoint formula, just the average of the x's, comma, average of the y's. Average means add up the 2 numbers divided by 2. So that's what I've shown here. 2 plus -2 divided by 2. -4 plus 6 divided by 2. So 2 minus 2 is 0, divided by 2 is 0, and 6 minus 4 is 2, divided by 2 is +1. So this right here is our center. I can write center over here now. So we have our center. Now we also need a radius, don't we? Because the center and then the equals the radius squared. Okay, so now that we have a center at 0, 1, and then both of these points are on the circle, so I can choose either one. I just chose 2, -4, plotted 2, -4. So there's my center. There's a point on the circle. And so I need to draw my right triangle, do Pythagorean theorem. So I did that, counted the number of spots, 5 and 2 here. So 5 squared is 25, plus the 2 squared is 4. 25 plus 4 is 29 equals r squared. Remember, we don't need to get down to r because in an equation, it's on r squared on the right side. Every time is never r. So we have our center. Remember, we do the opposite, opposite. The opposite of 0 is still 0. So, that would be 0, but we're not going to ever write it like this. It's not going to be written like this in the park. X minus 0 is still just x. This is how I want the answer written. Now, don't put the -0 in there. Just x squared. And the opposite of +1 is -1. So y minus 1 quantity squared. And then here already is my r squared, 29. Okay? And that will do it for this. So now you'll have a worksheet on that. And again, you can always refer back to this so you have all your examples you need. And have a good day. Bye.